Now, in this video, we are going to discuss about rest, motion and the types of motion. Now first, what is rest? There are two states of an object. First is rest and other is motion. Now first, what is rest? If an object doesn't change its position with respect to surrounding with time, then it's said to be at rest. And on contrary to it, if an object changes its position with respect to the surrounding, with time, then it's said to be in motion. Now what's actually these things mean? Suppose this is a body or an object A. These are another object in its vicinity or surrounding. These are the other objects, and we have to actually observe about A. Suppose this O is the this is the reference point. And this is point A. Now, if initially suppose A is at time t is equals to 0, A is at this position. Now suppose at time t is equals to t1, A is again at this position. Now at time t2, the position of A is going to be same. Now with respect to reference point, position of A is going to be remain same for all the time interval. Then we can say A is at rest according to its surrounding. A is at rest. But if suppose initial the position of A is this with respect to reference point, and after some time t1, say its position is here, let it be A1. Now at time interval t2, its position is this A2. Now at interval t3, its position is t3. Now every time we observe, the position of the object is varying with respect to reference point. Position is not same, it's varying with respect to reference point. So we can say this A is in motion. With respect to what? With respect to surrounding as well as time. With respect to surrounding and time, A is in motion. Now these two terms, A and rest and motion, both are related to each other. Rest and motion are relative states. It means if an object is at rest in one frame of reference, it can be in motion in another frame of reference at the same time. What it's mean? Suppose take the example of train again. In a cabin, a passenger is sitting. This is passenger A and these are another passenger B, C. Now a person, let D, is standing outside. Now if this train is moving in this direction, according to the other passenger B, C, A is appeared to be at rest. So if we consider a frame of reference associated with the train, according to that frame of reference, A is at rest with respect to other passengers, but according to a person standing outside, it's a frame of reference also associated with this person. According to this person, this A is moving in this direction, so it is in motion. So according to a frame of reference associated with the passenger or other train and passengers, A is at rest. But according to the frame of reference associated with the person standing outside the train, A is in motion. So what we observe that A is at rest and A is in motion simultaneously. So if a body is at rest according to one frame of reference, it can be in motion according to another frame of reference. So we can say that rest and motion both are relative terms. Rest and motion both are relative terms. Relative terms. Now next, types of motion. There are basically three types of motion that we consider, that is one-dimensional motion, two-dimensional motion and three-dimensional motion. First of all, what is one-dimensional motion? Now first, one-dimensional motion. If only one out of three coordinates specify the position of an object with respect to the time, then motion is said to be one dimension. Suppose motion of a block in a straight line, of a train along the straight track, or man walking along on a level or a narrow road, and object falling under gravity. These all are the example of one dimensional motion. Or one dimensional motion, 1D motion, when only one axis is required. Only one axis is required to explain the motion, then it's called one-dimensional motion. 2D motion, when the two axes are required to define the motion, then it's a 2D motion. Suppose like I'm writing on this page of this or on the screen, it's just required two, x and y axis say. So it's 2D. So motion in a plane is an example of 2D. Suppose next is 3D. Suppose an insect is flying in the surrounding. For 3D motion, three axes are required. Three axes are required. For example, an insect flying in a room. So if an insect is flying in a room, three axes means three coordinate x, y and z are changes. So it's a three-dimensional motion. So if only two out of three coordinates required to specify the position of an object change with respect to time, then it's said to be two-dimensional, like circular motion. Now three-dimension, if all the three coordinates are specifying the position of the object change with respect to time, then it's called three-dimensional. For instance, a bird flying, a flying kite, a flying aeroplane, and random motion of gas molecule.